This is a video on solving systems of linear equations with the substitution method. And so I need to solve for x and y simultaneously, and that causes problems. So what I need to do is I need some sort of method to kind of deal with one variable at a time. So substitution is usually the first way that you learn how to do this, and it works pretty good. So substitution works like this. Realizing that a system is going to, I want to find x and y. For me to use the substitution method, I have to have one of the variables. It doesn't matter which one, all by itself or isolated. So in this case, I have a y by itself. Okay? So this is set up pretty nice to do substitution. So what I'm going to do is I'm going to go ahead and circle the y's. And realizing those are the same y, so they equal to each other. Well, the whole substitution method works like this. Since y is equal to 2x plus 1, they're exactly the same. And everywhere I have a y, I could replace it or substitute it with 2x plus 1. It's the same thing, so I'm going to go ahead and do that. I'm going to come over here, and I'm going to rewrite this top equation here, but instead of using a y, I'm going to use what it's equal to, which is 2x plus 1. Okay. Now, if you look at it, I only have one variable, one unknown, now I can solve. So it's kind of weird with the parentheses, but I don't really need them because there's nothing to distribute. So I'm going to combine like terms. Subtract 1 to both sides, and I'm going to solve for x. Okay. Well, the thing we need to remember, the solution to a system is an x and a y coordinate. So I got the x, I need the y. Well, so I have to substitute an additional time. So now I know what x is. Everywhere I see an x, I can plug that in. So I'm going to come back over here. I'm going to say 2 times 1 plus 1 equals y. I'm basically using this equation. I know I put the y on the other side, but it's the same thing. And so I multiply, and I get y equals 3. So there's my actual solution right there. Okay. So you need to get one variable by itself to use substitution. Next example here. Well, when I look at this, I'm trying to use substitution. The first thing I do is see if there's any variables by themselves. So x, y, nothing is all by itself. Well, that's okay. I can solve for one. I can make this a lot easier on myself if I pick the easiest one to isolate. So this x has the least amount of stuff with it, so I'm going to go and isolate that one. So I'm going to go ahead and rewrite this equation over here, and I'm going to solve for x, because I believe that's the easiest one to get alone. Okay, so there's my equation. Now, where I got to be careful here, so I got x by itself, so I have to plug into the x of the other equation. Okay, now be careful here because I have this number out front here. So what I'm going to do is now take this value, plug it in right there, and this is going to be negative 3 times 3y plus 7 plus 16y equals 28. And I got the same result. I basically want to get this, so I only got one variable or the same variable in the question, right? And everywhere I see an x, I could replace it or substitute it for 3y plus 7. So now I'm going to use my distribution property here, and I get negative 9y minus 21 plus 16y equals 28. I'll combine like terms, and I'll get 7y. Because it's positive 16, negative 9 minus 21 equals 28. I'll add a 21 to both sides, and I get 7y equals 49. Okay. Go ahead and keep solving here, and y equals 7. So remember, I want a coordinate point, and I've got the y value. So now I got to find the x value. And I can plug into any equation that I have up here to find the x. Some are going to be easier than others. I really like this one here because the x is by itself. So I'm just going to draw a partition there, and I'm going to plug it into this one. And like I said, I could plug into that y or that y, and it'll all work out. And so that is my answer. 28, 7, coordinate point. One last example. So looking at this same thing, I want a variable by itself. It looks like the easiest one to get by itself is probably this y. So I'm going to go ahead and bring that over here to give myself some room to work. And I'm going to subtract 2x. Remember, these are not like terms, so I can't combine them. Oops, sorry. To x plus 5. I'll divide everything by a -1. And y, a negative and a negative is a positive. Okay, is that. So now I got a variable by itself. Yeah, it's y. Now I isolated this one, so I got to plug it into the other equation. So it goes right there. So I'm looking at 3x plus 4 times 2x minus 5 equals 2. I'll go ahead and distribute. Combine like terms. Okay. I'm going to add 20 to both sides. And I get 11x equals 22. I'll divide by 11. And x equals 2. Okay. So I've got 1 point to my solution. So I'll go back and I got x here, so I'll plug into that x. So I'm going to say y equals 2 times 2 minus 5. Y equals 4 minus 5. And y equals -1.